All right, hello everybody. So it turns out I screwed up the recording for yesterday's lecture. So I just re-recorded it and uploaded it to YouTube. I'll post a link on the lectures page after this lecture. All right, so again, I have to let you know I am recording. Oh wait, this says stop recording. Does this mean it's actually recording? I guess it's actually recording. Oh, I see. Someone else started the recording. Maybe that's what happened yesterday. Interesting. All right. So what happened yesterday was I have the first 3 minutes and I have the last 3 minutes. I'm not exactly sure. So I thought I had screwed up recording, but I guess it's possible if someone else started the recording, maybe that's what happened. Anyway, it's not important. All right. Today we're going to talk about a little bit about the history of Linux, so probably 15 or 20 minutes. And then I'm going to talk about the file system, which is I guess it's probably the most important part of the operating system that we deal with in this course. Let's see. So to begin with, I want to again show you some more silly Linux fun. So even though this is just a plain text console, right? So it's just text, right? It's not an actual graphical program. People have been able to do some pretty amazing things for it. Oops, sorry. Come on, Pac-Man. There we go. So for example, you can play Pac-Man in your console, which is kind of crazy, right? So you can use the cursor keys and you can move around the C. That's Pac-Man. And you can, yeah, you got the full-blown version of Pac-Man in your console here. Now, obviously we're not going to get to that point in this course, but you know, I'm just showing you can actually do some pretty impressive things in the console. Okay, so again, if you're on Windows, it's easy to. If you're in Linux or Windows, it's easy to install. If you're on a Mac, you'll have to search for how to install that thing. There must be a way to do it. I just don't know what it is off the top of my head. All right. So in these types of courses, it's always useful and interesting to look back at the history of, in this case, the history of Linux. When we get to talking about C, I'm also going to talk a little bit about the history of C, but only for 15 or 20 minutes or so. Now, Linux is one part of what's more correctly called the GNU Linux operating system. So Linux is what's called the kernel. Now, the kernel of an operating system, that's the interface between the hardware and software applications. In a modern operating system, though, when people talk about operating systems, it's not, people generally mean the kernel plus other stuff. So there's other software. And so the other software is the GNU part of this GNU Linux thing. Now, Linux is modeled on an older operating system called Unix. And Unix is an operating system that was developed starting in the late 1970s at what used to be called Bell Labs. I'm not sure if Bell Labs is still in operation or not. That's the American, Bell Labs was the American Bell. You know, Bell Canada, well, there was a Bell USA too. Bell Labs was part of that big conglomerate. Unix, so this is 1970, so computers were just starting to show up in wider use. You still couldn't go out and buy a desktop computer, right? So these computers, these are big giant boxes that I'm going to show you in a second, sitting in a room somewhere. Several hundreds of thousands of dollars to buy, which in the 70s was a lot of money. So basically what happened, there's a few vendors of these computers. Every vendor would have a different operating system or no operating system. They would just build the computer. And Unix was developed Unix was developed in the 70s at Bell Labs, and it became one of the first portable operating systems. So portable means you could actually take it and run it on and have an operating system for a different computer. And the reason it was portable is because it was actually written in C instead of some other proprietary language. So when we get to the C part of the course, I'll tell you a little bit more about that. Problem with Unix is it's not free or open source. And in particular, it's very expensive for individual users, right? Assuming you could even get, assuming an individual user even had access to one of these giant computers. All right, so let's take a quick look at where to go. Where's my, here. All right, so Unix. What is Unix like here? Unix. Okay, so Unix was, see here, right? It started in, development started in 1969. Originally intended for use inside of Bell, right? And then it became licensed to other vendors and became an operating system that you could buy and run on your, and run. Right, is there anything here useful? So if you hit that link on Wikipedia, you can find out more about the history of Linux and so the history of Unix. That's the sort of computer that this thing was that Unix would be running on. So this is a PDP-11 computer, which you can find out about if you hit that link there. Right, you can see that eventually they sold about 600,000 of these, which made it quite successful for the time. Right, obviously 600,000. That's not very many computers in today's numbers. Right, Ken Thompson, Dennis Ritchie, these were the two people who ended up developing the C programming language that we're going to learn about later. All right, now, so that's the Linux part, right? So that's the kernel part of the Linux part. The GNU part comes from the GNU project, which was started by it was started by Richard Stallman. And his goal was to create a free Unix-like operating system, right? Again, because Unix, to get an actual Unix operating system was very expensive. Now, so him and the people that were working with him, they developed the tools that you needed for kernel development. Right, so basically they wrote a C compiler and various development tools. Right? But what they didn't do is that they didn't actually write the kernel. So the goal was to create a free, like an entire Unix-like operating system, including the kernel. Their kernel they called Herd, right? But it never really fully developed into an actual kernel until relatively recently, actually. So that was 1983. Right? 8 years later, there was still no kernel that was part of GNU. This Finnish graduate student, I think he was a master's student at the time, by the name of Linus Torvalds, announced on Usenet. That was a very early. That's a very early what's called a bulletin board. So it's very early social media network, I guess you'd call it in some ways. Although no one back then would have called it a social media network. Said he was going to develop a free operating system just for fun. And he was targeting 83, 86 processors. So that's that's an early Intel processor. I think most of you would not have used a computer with an IA386 in it, with a 386 in it. So he started writing the kernel. He could do that because he had the software written as part of the GNU project. So he had the compiler and the development tools to write the kernel. GNU never actually finished their kernel until recently. So what ended up happening was people took the GNU development tools, they took Linus's Linux kernel, and thus was born the Linux operating system, what is now called the Linux operating system, right? So that's what people mean when they say GNU Linux. Today, Linux dominates certain parts, certain computing is dominant in certain areas of computing. So cloud infrastructure and supercomputing is almost completely dominated by Linux, right? So I think the top 500 supercomputers in the world all run Linux. Cloud infrastructure, that's the stuff that Amazon and Google and Facebook run on, right? All Linux, right? Now, you might wonder why it's Linux and not something else. Because you can build cloud infrastructure with, say, Windows or Unix. So if you look at, not usage share, where is it? Right. So if you Google how many servers does Amazon have, right? Now each server is a separate computer. So it needs its own operating system. Amazon, just Amazon alone, runs an estimated 1.4 million servers. That was in 2014. It's probably a lot higher now, right? So if you had to pay a Unix or Windows licensing fee for every server, you're spending a lot of money just to pay for software licenses, right? Linux is free, which is why, or one of the reasons why it shows up so much in cloud infrastructure. Android is the world's most popular operating system, I believe. It runs on more than 70% of smartphones. It's Linux-based. Embedded systems, there's a lot of Linux, so your router probably runs a version of Linux. Now, on the desktop, it's quite uncommon, unless you include Chrome OS. Chrome OS is Google's operating system. It's common on cheap laptop computers, which a lot of kids in the United States happen to run. So a lot of kids in the US get them for, I don't know if they get them for free or whether the schools provide them or how it works, but a lot of kids use them. So it turns out it's actually quite common if you count them. If you're curious about what operating systems are run where, you can look at the usage share of operating systems. Right. Let's see what we have here. So Android, most commonly used operating system in the world when judged by web use. Right. So 41% of the global market is Android, followed by Windows at 32%, and then Apple at 16%. Right. If you look at just desktop computers, Windows is the most popular still. Right. Mac, pretty popular. Now, if you look at Linux, desktop Linux, it's about 2%. So it's not super common. Although it's easy to install on any non-Mac computer, right? So it used to be very hard to install. Like you basically try to install it, you'd cross your fingers, hope everything worked. Nowadays, most modern Linux distributions will install on a modern computer with relatively little pain, right? You might run into problems if you have a really, really brand new computer. But if you have a computer that's a couple years old, Linux should install on it without any issues. So if you want to try installing it on your computer, I would encourage you to try doing so. Okay, now occasionally you may see the term Posix, right, which looks a lot like Unix and Linux. Not quite the same thing. So Posix is a set of standards. The standards, it's called the Portable Operating System Interface Standards. So it's a set of standards for maintaining compatibility between operating systems. So basically, there was an organization that tried to that recognized there's lots of different operating systems, and they tried to come up with a set of standards so that it would be relatively easy, I suppose, to move software between different operating systems. There are some operating systems that are certified to meet the Posix standard. Right? So these are the vendor-supported Unixes, of which there aren't very many anymore. Right? So IBM and HP would be the two large ones who still support Unix. Mac OS, interestingly enough, is in fact Posix certified. Linux is not Posix certified, but it's close. It's mostly compliant. So it doesn't quite meet the standard, but it, for the most part, it's considered a Posix-like operating system. Windows is not. So Windows does not meet this standard. So if you've ever seen the term Posix, that's what people are talking about. All right. Bash. So terminals. Now, I've already shown you an example of a terminal. This thing here is a terminal. Right? This is a virtual terminal. It used to be the case that the terminal referred to some sort of electromechanical device for data input and output. Okay? So data goes in, right? You can enter data, you can look at data, right? That's what a terminal used to look like, right? So it used to, even earlier, they wouldn't even have something like this. So this thing here is a printer and a keyboard, right? To enter commands into the computer, you type on the keyboard. There's no monitor. You type and hope for the best, right? To get the output, it would be printed on a piece of paper. That's a slightly more modern, slightly newer computer compared to this, right? So here's a computer with a terminal, with a visual terminal built into it, right? So keyboard, monitor, right? That thing there looks a lot like this thing here, right? And so this thing is still called the terminal, right? More properly, it's called a terminal emulator. So if you're in Windows and you run the Windows subsystem, right, you get that. If you're in Mac, you can open up a terminal by finding your terminal program, and you'll get something that looks like this, right? So these are all examples of terminal emulators. Inside the terminal is a piece of software, right? So the terminal, that thing here, is running some software which is called the shell. So the shell is the software that interprets text to determine meaning, right? So when I'm typing in commands into the terminal, right? So when I type in, say, the ls command, right? It's the shell that interprets ls, right? And then decides that, oh, I need to run the command that corresponds to ls, right? Now, it turns out there's a lot of different shells, right? So the one that we're most concerned, that we're interested in is bash, right? So bash stands for the born again shell. It replaces the older Unix shell, one of the older Unix shells called the born shell. So most Linux distributions use bash as the default login shell. Mac OS used to use bash until 2019. And now they use Mac uses the Z shell. Right now, CISC220 assumes you're using bash. Okay, so if you're on a Mac, you have to be a little bit careful about. You have to be a little bit careful about some of the commands that you use, because some of the commands that are part of the Z shell are not exactly the same as the bash ones. For the most part, this won't matter, because you'll be handing in scripts, and your script will have a line that says which shell should interpret the script. And so the line that you'll put in is the line that says to use the bash shell to interpret the script. So normally this shouldn't be an issue. But if you're just typing things straight into your terminal and they don't quite work the same way on Mac as I'm showing you on Linux, then the reason is because your shell is different. Okay, so the file system. Oh, do you have recommendations for dual booting Windows and Linux? I don't know what type of recommendations you're asking for. So exactly what are you asking for? So in terms of recommendations. Like you mean like which version of Linux should you use? How should you set it up, et cetera, et cetera, et cetera? I can tell you how I do it. If you have a desktop computer, the way I do it is I buy a new hard drive. Right, so I buy a second hard drive and stick Linux on the second hard drive. You can, if it's possible to put it on a single hard drive, but that means you have to partition your hard drive, your Windows hard drive. So that is something that you don't really want to do if you've never. You have to be a little bit careful when you do it, because you can lose data that's on your Windows hard drive. Hard drives, discs are cheap these days, right? So under $100, you can buy a new disc. So, so I always buy a new disc whenever I want to put in a new version of Linux. But you don't have to do it that way. If you want a recommended version of Linux, then Ubuntu is the most popular. I use Mint, but Ubuntu is by far the most popular. Okay, your file system. So that's part of your operating system. It's the part of the operating system that controls how data is stored on physical media and then retrieved from physical media, right? Well, it's the part most often associated with physical media. It's not the only way, right? So if you have a disk, right, a USB drive, optical media. So if you still have a CD reader, for example, none of you will have magnetic tape, I don't think. Then all of these devices are accessed via the file system. Now, there's many different file systems, right? So if you're on Windows, Windows is going to be using one of these three, probably NTFS if you're on a newer Windows computer. Mac OS has its own file system called the Apple file system. Linux has many, many, many different file systems. Now, the user doesn't actually normally care about the file system that they're using, right? So if you're on Linux, for example, you don't care if you're using ext3. Well, the average user doesn't care if you're using ext3, ext4, or whatever. So a device is a physical piece of hardware that can store files. So your disk drive, USB flash drive, CD-ROM drive, these are all examples of devices. Right now, every device, so it's a piece of hardware, right? So every device is going to have a different way of using the device, right? So when you want to write something to a disk drive, that's going to be different than writing something to a USB flash drive. That's different than writing something to a CD-ROM drive, right? Again, the user doesn't care, right? All they care about is that they want to write something to their storage device, right? So it's the operating system that takes care of abstracting these devices. So the operating system provides a unified interface, programming interface, that can be used by another program to write something, to write and read information to a device. Now, the question is that we're interested in for now is exactly what abstraction is your file system providing? Right? So if you have a file, right, now your file is just a piece of digital information, which means it's just ones and zeros, right? It's just bits. So for the time being, let's imagine that your operating system abstracts your disk drive as a big array of bits, right? So you all know what an array is at this point in time. Right? So imagine that your disk drive is modeled as a giant array. Okay, that's it. So it's just a big empty array. All right, so here's a picture of an array that's storing many different files. Right? Each file is a different color. Okay. So the red file, that's file 1, the green file is file 2, the blue one's file 3, right? And so on and so forth. You can see each file has a different size, right? Now, the operating system needs to store some information for each file, right? So your operating system needs to know where is file 1, right? Where is file 2? Where is file 3? And so on and so forth, right? So at a minimum, right, the operating system needs to store where is the beginning of file 1, right? Where is the beginning of file 2? Where is the beginning of file 3? And so on and so forth, right? So in other words, the operating system needs to store the starting location of each file, right? Now, what other information might be useful or necessary for each file, right? So, like, what do I need to know about file 1? Well, I need to know where it starts, right? You probably want to know how big it is too, so that you can figure out where it ends. Right? So you want to store the size of every file. Right? So what else does the operating system have to store? Well, let's take a look at something in here. Okay. So if you're in Windows, you know that you've got Windows Explorer, right? So here's your file browser, right? Called Explorer in Windows, right? That lets you look at the files in this case the files in the Windows file system, right? So you can see here, this is my documents folder on my computer. I've got these are all the courses for this year are in this folder, right? all the courses from past years are in this folder. These are the courses that are still going on because of the stupid pandemic, and so on and so forth, right? On this computer, there's actually two separate file systems, right? There's the, well, that's not exactly true. It looks like there's two. There's one managed by Windows, there's one managed by Linux, right? So if you're in, if you ever want to get a visual or a graphical explorer for Linux, right? On Mac, you just use the Mac native file explorer, right? On Windows, you can type in explorer.exe inside of your Unix terminal, sorry, Linux terminal, right? And so explorer.exe space dot, right? And that will open up Windows Explorer in your Linux file system. When I do that, I get this, right? And you can see here that the way Windows manages the Linux subsystem is it makes a network drive called WSL, right? Under that is my operating system Ubuntu, right? And then you can see here all the files that are inside my Linux file system that's on this Windows computer. Okay, now we were talking about the file system and what other information might be useful to store for every file, right? So Explorer gives you some hints, right? The date at which the file was modified, that might be useful. Right? The size of the file might be useful. Right? The type of the file, that might be useful too. And there's, you can imagine that there's a whole bunch of other information that might be interesting for each file. Right? So in particular, right, stuff like the file size, who owns the file, when was the file created, when was it last modified, when was it last accessed, and a whole bunch of other stuff is information that's useful to store for every file. So in Unix and in Linux, there's something called an inode. Right? So an inode is a data structure. So an inode stores information about the contents of a file. Right? So it tells you stored in the inode is what device, on which device is the inode located? Right? What is the file type? Right? Who owns the file? Et cetera, et cetera, et cetera. What's not included here is the name of the file. Right? So an inode doesn't store the name of the file. Every inode has an integer number called the inode number. Right? So the inode number is a unique ID for the inode on a given device. Now, different devices are allowed to have inodes with the same inode number, right? So if I have two hard drives on my computer, those are two different devices, right? I might have an inode number 10 on my first hard drive. I might have another inode number 10 on the second hard drive, right? So inodes are unique per device, but they are not globally unique for the file system, right? Okay, so if your file system is represented as a bunch of inodes, right? How does the file system record the file name for a file, right? Because the inode doesn't store the file name information. So instead, there are these things called directories, right? So a directory, most of you, oops, sorry, wrong one. Most of you will know as a folder, right? So when you click on a folder, in this case, home, right? Unix and Linux use the terminology directory instead of folder. So what's a directory? Well, a directory is just a file. So it's a special type of file. So that means it also has an inode number. But the content of a directory, it's just a table, right? So it's a table and it maps file names to inode numbers, right? So for example, if I list the contents of my home directory, I might get something that looks like this, right? So if I type, so I might have a file called dir1. That's actually a directory, right? It's a file still, so directories are files, right? So it has an inode number, right? So it's got the inode number 45201. I might have a second directory called dir2, and it has the inode number 45212, and so on and so on and so forth. Right? These are all unique because all of these files are living on the same device. Right? So your file names are stored in a file. Strange, but that's the way it works. Right? The file happens to be a directory. Right? And your directory is just a table mapping file names to inode numbers. Right? So that's how Linux and Unix that's how their file systems work. The inode is actually this thing here, so I'm leaving out a lot of information that's not relevant to us. But there's actually a lot of information stored in an inode. Okay, so in Linux, there's a standard directory. There's supposed to be a standard directory structure. Mac OS uses a similar but different structure for their operating system hierarchy. Right? So if we go back to Explorer, where to go? Here. Right. So if I go back up to the here into Ubuntu 20.04, right? So that's the start of my Linux file system. Right. You'll see that there's a bunch of files here. Right. So there's a boot, there's a dev, there's an etc, there's a home. Right. There's quite a few of them actually. Right. These are all part of the file system hierarchy standard, the Linux file system hierarchy standard. Right. Now we don't need to study this in detail. It's useful to know something about this. Right. One of the most important things you need to know is that in this standard there is a top level or uppermost directory. Right. It's named slash. So that directory slash contains all other directories. Right. So slash is also called the root directory. So what I'm showing you here, this is the contents of the root directory. Right. So that's what it looks like in Explorer. If you want to get to it from the command line, so the way you get to it from the command line is you type in the command cd. So cd is change directory, right? And then you type in the name of the directory that you want to go to. So I want to go to the home directory, so I type in cd space slash. Notice that at least in so in Windows, right? In Linux, right? In the bash shell, usually you'll end up seeing the directory name here. On Mac, I don't know if you see the directory name here or not, right? But it's now telling me that I'm in the home directory. If I type ls, right, it tells me that there's all of these things in the home directory. Anything in blue is another directory, right? So dev is a directory, boot's a directory, home is a directory, so on and so forth. Right, so there's our first command of the day, cd. Right, if you type in man cd, you see that there's no manual entry for it. So cd is what's called a built-in command. Right, in other words, it's part of the shell. Right, all of these other commands like ls. Right, so if I do man ls, right, I actually get a man page for it. It turns out ls is a command, is a separate program that's not part of the shell. cd is a command that the shell understands natively. So if you want help for the built-in commands, it's man built-ins, right? And now you can see that there's a, you can get the list of built-in commands here, right? And if you go poking around, you will eventually find cd. Here it is. Right. So if you're wondering why cd doesn't show up when you type in, or why a man page doesn't show up when you type man cd, it's because it's a built-in. You have to look in a different place for help. Okay. Go back to here. So I just did this, right? So there is it is written down for you if you so you don't actually, you can just read the lecture slides instead of having to follow through a video. Okay. Now, when you just have a terminal, right? So in a graphical program like this, it's easy to know where you are, right? So I can just look up here and I know I'm in the root directory, right? If I click on home and then Burton, right, I know that I'm in the home Burton directory, right? It's easy to tell. If you're in a shell, sorry, if you're in a terminal, or if you're in the terminal, right, it's less easy to determine where you are. although sometimes you can find out by looking there. So the command pwd is short for print working directory. So it will print out the directory that you are currently in. So when I type pwd in the root directory, it tells me that I'm here. Just let me check something quickly. To see. Okay, so that doesn't tell you. So notice here, I get the twiddle, right, or the tilde. So that doesn't tell me which directory I'm in, unless you know what that means, right? So if I do print wd in that directory, right, it now tells me that I'm in the directory root, home, Burton. Let me go back to the root directory. Okay, so pwd, that's the command. It is a built-in, so that's the command that prints out the current working directory. Oh, hold on. Sorry, it's hard for me to keep track of the chat and the lecture. Does the inode include where to find the file in case it's the content? Aha! David asked a very good question. Sorry, 10 minutes ago. Let me go back. That was a great question. This picture here that I'm showing you is not at all representative of how it actually works, right? So here I'm saying this was just a simple example. This is the simplest, I think this is probably the simplest possible way that you can store files, the contents of each file, right? So the contents for file 1 are contiguous, right? They eat up a continuous chunk of the array. That's not how it works. The contents of file 1 in real life are broken up and they're all over the place. So you'll have a chunk of file 1 here and 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 here, right? Included in the inode are is information that says where the different chunks are located. Right? Exactly how that works is way beyond the scope of this course, right? But the inode does include where to find the file, pieces of the file. That's a good question. I'll get to the tilde in a second, actually, I think. Pretty sure. Right. So yesterday I showed you the ls command, right? If you ever want to know what's in the contents of a folder, or what the contents of a folder are, you just type ls and that lists the contents of the directory. Right? You can ask for the contents of a specific directory if you want. Right? So I can type in ls home. I can list the contents of the directory home and root. Right? I can type in ls. If you just type in ls, you get the contents of the current directory, right? But you can ask for the contents of more than one directory at the same time. So I can ask for the contents of ls home, and I can ask for the contents of ls, let's do etc. So this will list the contents of the home directory, and it will list the contents of the etc directory. And you can see there's a lot, right? So in etc, there's a whole bunch of stuff, right? In home, there's just this directory, right? Home is the directory containing all of the user directories. So I'm the only user on this computer, which is why there's only one directory in the home directory. Right? If you are on a shared computer where there's lots of different users, each user will have their own directory under the home directory. Okay. Built-in commands. I think I already talked about this. So there is a distinction between built-in shell commands and other commands. Right? The built-in commands are commands defined by the bash shell, and other commands are just programs that can be run by the bash shell. Oh, I already told you all this. Sorry, I'm a little bit out of order. Right? If you ever need documentation, if you ever type in man and something and it says there's no man page for it, in this course there's a good chance that it's a built-in. So you can type in man built-ins to get help there. And we've done this already, right? I showed you this yesterday. Okay. So the standard file system, the standard hierarchy for a file system in Linux looks something like this, right? It's actually more complicated than this. I think I have a web page up that tells you exactly what it is. Here. So there is a Wikipedia page for this. The standard says that all of these directories should exist. There should be something called root, right? There should be something called bin. and then so on and so on and so on and so on. Right? Again, it's not important for this course that you know all of this, that you memorize what directories are here. Right? It's useful to know something about the standard, though, in case you need to find out where something is on your file system. Right? Home in particular, that's going to be the one most useful to you because that's where all the user home directories are. Right? Bin, that's where the essential command binary files are found. Right? So a lot of the commands that I've been typing in, they live in bin. Root, that's the root directory. That's where everything else lives in, right? USR, that's another hierarchy for read-only user data, right? So if you install software on your Linux computer, there's a good chance that it's installed somewhere under the user directory. Right, I showed you this, right? So we can list the contents of a specific directory, right, by typing in the name of the directory that you want to look at. You can see in the bin directory, there's a lot of stuff, right? So anything in green, that's a program, that's a runnable program, right? So an executable program. You can see that, what's in here? Well, first of all, you can see that there's a lot of stuff in here. Can I find something that we've used? All right, you can see that ls is here, for example, right? So ls is a separate program. It's found in root bin, right? When you type in ls, it's this program that's running, right? And you can see there's a whole bunch of stuff in this directory, right? So there's actually a lot of software that's installed in a modern Linux distribution, right? Oh, we used the cal program the other day. So there's cal, right? Cal is actually short for calendar. So there's the actual program that's run. Right? Obviously, we're not going to look at all of these commands in this course. All right, what time do we have here? Okay. So there's something called an absolute path name. Right? So an absolute path name, that's the name of a file that uniquely identifies the location of a file. So what that means is the absolute path name includes all of the directory names that lead to the file. Right? In Linux, the slash, oh, wait, sorry, I can't do that in PowerPoint. The slash character separates directory names, right? So that's a bit confusing because slash is also the name of the root directory, right? So slash on its own means the root directory. So that's an absolute path, right? That's the absolute path to the root directory. Slash bin, right, is the absolute path of the bin directory. The program ls, its absolute path is slash bin slash ls, right? And if you want to look at the exam for this year, right, that's slash home slash Burton slash CISC220 test exam.pdf. It includes the full path that you need to get to the file, right? So that's the absolute path name. Now, you don't normally use an absolute path name, right? So normally, what you use is what's called a relative path name, right? So a relative path name includes all of the directory names that lead to the file, starting from the current directory, right? So, for example, suppose that I'm in this directory here, home Burton CISC220. So let's go there. I'm going to go to home CISC220, right? So I've used an absolute path to get to the CISC220 directory, right? So I'm now inside the CISC220 directory right there, right? Okay, now suppose I have a directory called tests inside CISC220, right? Inside tests, I have a directory called exam, right? Inside the exam directory, I have exam.pdf and exam.docx. I don't know if I actually have those. I bet you I don't. Right? Then the relative path to exam.pd. Sorry, I did it again. Sorry. Okay. Okay. So the relative path to exam.pdf, right, is tests exam exam.pdf, right? The absolute path would be all of this slash tests exams exam.pdf. right? So if you're in a directory, like CISC220, right? Then I can list, or I can get to the, I can list the contents of exam, right? So this is using a relative path, right? I'm asking for the contents of exam, and I can do that because I'm inside the CISC220 directory, right? And you can see that there's a bunch of old exams here, right? I can do the same thing using an absolute path, right? So I can do home, Burton, CISC220, exam, right? That'll give me the same thing, right? So for the most part, you use absolute paths. Sorry, you use relative paths because there's a lot less typing, right? Okay, so we've actually done this too. So if I'm in the root directory, I can list the contents of any other directory using a relative path, right? So if I want to find the contents of bin, I can type in ls bin. Now notice I'm not in the root directory right now, right? So I'm in that directory. So if I type in ls bin, that's not going to work, right? Because I'm using a relative path and there's no bin directory in the CISC220 directory, right? However, if I'm in the root directory, there is a bin directory right there, right? So now I can use a relative path to find the contents of bin, right? And there you go. So that works fine, right? And you can try these examples too, right? Any command that requires a path name, well, I shouldn't say any command. Any command that some random person hasn't written, right? So any command that's part of your Linux distribution, if it needs a path name, it will accept a relative path name, right? So you don't have to use absolute path names. It could be the case if you write your own program. It's possible to write a program where it will only accept absolute path names. But most of the Linux commands, if they require a path, will accept a relative path. Okay, the cd command, if you type in, all right, so if I just type cd on its own, right, so I don't, if I don't put in any other arguments to the cd command, right, then on its own, cd always takes you back to what's called your home directory, right? So home Burton, that's my home directory. If you set up Linux on your own computer, then when you type cd, it'll take you to home / whatever your username is that you chose. Right? Mac, I don't remember what the file hierarchy structure looks like, but it takes you to your home directory on a Mac computer. Why is the user directory read only? Is the user directory read only? I don't think it is. CD. Okay, user is, so we'll get to this in probably a couple of weeks. User is not read only. It's so user has read, write, and execute permissions if you're root, right? So if you're the administrator of this computer, you can go into the user directory and do whatever you want. For me, those will be my permissions. So those will be the other permissions. So that means I can read and I can execute, which means I can change into the user directory. So I can actually go into the user directory and look at its contents. It's not read only. It's read only to, well, it's not read only to everybody, right? There are users on this computer who can go into that directory. But we'll talk more about permissions later on. Right, cd on its own changes to the current user's home directory. All right, this tilde thing, right? On my keyboard, it's the upper leftmost key on my keyboard. It might be somewhere else on yours. Tilde is short for the user's home directory. You can change it if you know how. Oh, it said on the slides it's read only. Yeah, sorry, it's read only to the to non-super users, right? To non-administrators. Sorry, David. So tilde is short for the users, for the home directory of the current user. So if I type in cd tilde, that also takes me to my home directory, right? That's why the tilde gets printed here when you're in your home directory, right? So tilde, that's short for the user's home directory. It's possible to change where tilde points to, though. You can look it up if you want to know how to do that. It's not very useful, I don't think, to change it, but you can change it if you want to. Dot. Okay, so dot has a special meaning. cd dot. So okay, print. Right. So I'm in my home directory right now. If I type cd dot, it goes nowhere. Right. So dot, that's short form for the current directory. Right. So in this case, dot is that directory there. Right. If I change to the CISC220 directory, right, then dot, now the CISC220 directory. Right. If you type in ls dot, that lists the contents for the current directory. Right. The reason dot exists is because sometimes you need to use it to specify a path. Right. And we'll see examples of that later on. Dot dot. So dot dot represents the parent directory of the current working directory. What do I mean by parent directory? Right, so it's easier to see what a parent directory means in a graphical application like this. Right, so right now I'm in my home directory. Right, if I go into CISC220, right, the home directory to CISC220 is the one that it's inside. Right, so it's actually Burton. Okay, so there's CISC220. The home directory of CISC220 is that directory there. If I go into exam, right, the home directory of exam is the one above it. Right, so that's CISC220. Right, if I go into 2019 fall, right, the home directory of that is the exam directory. So in the terminal, if I want to go up one directory, just type in cd dot dot. Right? That takes me to my home directory. So one more time, right? From the home directory, I go to CISC220. If I want to go back up, I type in cd dot dot, right? And that takes me to my home directory. Okay, so let's go back into CISC220. Let's go into the exam directory. Right, I'm in home Burton CISC220 exam. Right, if I'm in the exam directory and I want to go back up to the home to my home directory, right, I can type in cd tilde. I can just type in cd, or I can type in cd dot dot slash dot dot. Right, go up one directory and then go up another directory. So now I'm back in my home directory. Okay, so let's try one more thing. Exam, let's go to 2019. So I'm in home, Burton, CISC220 exam. Oh wait, I'm way over time. Someone should have said something. Sorry. I have to let you go. You have other classes to get to, probably. I'll end it there. And then I'll pick this up on Friday, I think. Friday. Right. So I'll finish up this lecture on Friday and move on to the next one. Sorry about that. Next time, someone please unmute and let me know that I've gone over time. All right.